Having seen the video on dual platonic solids, I thought I would attempt to try to show you this video or show you an explanation of the video one more time for at least one figure, and that would be the cube, and to see what its dual is. Now, it's hard to picture this because it's a three-dimensional idea on a two-dimensional surface. But if we had a room, as Mike said, that was totally and exactly in the shape of a cube, if it was a platonic solid cube, we could do the following. What we could do is we could locate a point in the center of each face of the cube. So I'm going to attempt to do that now. So here is one at the ceiling. Here is one right in the middle of the face on the floor. Here is one point located in the middle of the face to the right. Here is where probably the face or the point would be in the middle of the face for the back. Over here would be probably where the dot would be, that would be in the center of that face. And then of course we have the front, which would have a dot right there. Now, it's a little difficult to see this. What I'm going to try to do is I'm going to try to hook together all of those points that are in the middle of those faces. All right? So I'm going to do that this way. First of all, I am going to hook them together. All right? Well, let's use a solid line here. But I think what I'm going to do is I'm going to realize that they are all inside the figure, right? So I'm going to use a dotted line here, all right? So we'll do it like this, all right? And I'll go over here, and now I'm going to hook a dotted line from the center of the top to the face in the back. Then I'm going to hook together the dot to the front face, the dot on it. And then I'm going to hook together the face over here on the left with the dot on the top. And then I'm going to hook the face together over here, which is right there. Whoop, I didn't do that right. Excuse me. I should have done it like this, sorry. What I hooked together on this one was the back face and the face on the right. Okay, I didn't go from the top point like I should have. Okay, now I'm going to do the same thing from the bottom face, okay? So I'm going to go up to the right. I'm going to go up to the back face. I'm going to go up to the front face. And then I'm going to go over here, across to this face. Now, if I hook all the dots on the faces together that are on the vertical faces, it would look something like this. I would hook that one together. I would hook these two faces together here. I already, by error, had hooked this face together. And now I'm going to hook this one over to here. Now you can see, now I didn't get my dots really that well positioned, but you can see a figure that resembles an octahedron in there, right? And it appears the face I really messed up on the worst was this one here. It was on the front. It probably should have been down here a little lower like this. So if I move each of these to the right locations, it'll probably look a little better. That would go down there. This one would move here, like so. That looks a little bit better, okay? So you can see that I have formed, it's not perfect, but I have formed an octahedron inside of there by hooking together the center points of all the faces. Okay, now having done that, This is what happens when you hook together the centers of the faces of the tetrahedron. It is itself its own dual, because a tetrahedron forms another tetrahedron, okay? Here's a better rendering of the cube and the octahedron that you get as its dual by hooking together all the faces, but I've tried to show it to you on the other situation at first to give you an idea of how they were hooked together, all right? And last but not least here, we have the icosahedron inside of the dodecahedron, and that is a pretty good rendering of that. So there are the dual figures. You can look at the bottom of your Platonic fact sheet, and the drawings are also there, all right, so that you can write down what they are. They are not noted, I believe, on your sheet right now. They will be on a sheet I will give you later, but right now they are not noted. So you might want to put down for the octahedron and the the dodecahedron and the icosahedron, just simply write dodec and icos below that figure so you know they are duals of each other. And for this one, put cube dash octa, all right? And for this one, tetra dash tetra, and that way you'll be able to remember which figures are duals of which figure. Now, the question often is asked by a lot of students, why are there only 5 Platonic solids? Well, there's a way to answer this question which is quite complex, and I used to teach it that way, the complex way, but I felt that it wasn't that useful to people, and I quit doing it that way. So I'm going to let the author show you the more commonsensical way as to why there are not more than 5 Platonic solids. So here once again is Dr. Mike, and he is going to talk about why there are only 5 Platonic solids. So here you go, take a look.